Okay, here comes the second part of our lesson. And what we're going to do now is, given 3 points, we're going to find the quadratic function that passes through them. Now, you couldn't necessarily just pick any 3 random points. They have to actually fit on a parabola. But this should remind us of when we had 2 points and we found the equation of a line. So it's kind of like that. So remember that the standard form equation of a parabola would be y equals ax squared plus bx plus c. And we're given 3 ordered pairs, 3 sets of x and y values. And ultimately what we need to know is, what is the value of a, what is the value of b, and what is the value of c? So really we have 3 unknowns, and we have 3 ordered pairs. We're going to be able to make 3 equations. So I'm going to take the first ordered pair, -2, 30, and substitute -2 in for x and 30 in for y. And we get 30 equals a times -2 squared plus b times -2 plus c. And that simplifies to be 30 equals 4a minus 2b plus c. And then the second point, 1, 6. So 6 equals a times 1 squared plus b times 1 plus c. So that equation is 6 equals 1a plus 1b plus c. And then the third one is 36. So we have 36 equals a times 4 squared plus b times 4 plus c. And so that equation is 36 equals 16a plus 4b plus c. So here we have a system of 3 equations and 3 unknowns. And we know a few ways to solve that system from last chapter. So suppose I decide to use the inverse matrix method. So I'm going to set up matrix A, which has the coefficients of A, B, and C. So 4, -2, 1, 1, 1, 1, 16, 4, 1. And then I have my variable matrix ABC. And then I have my coefficient, or I guess, my constant matrix, 36 and 36, and that's matrix B. And to solve for ABC, we're going to take A inverse times B on a calculator. So this will be a good chance to practice that. So I'll remind you what to do. So you have your calculator, and you go into the matrix menu, and you go over to Edit, and then you can select matrix A if you want to, and this will be our 3 by 3, and we're going to type in our numbers. Okay, and then just always double check and make sure that you type them in correctly, and then we can go back out and then go back into the matrix menu, go over to Edit and down to matrix B. And let's make this one a 3 by 1. And the numbers were 30 and 6 and 36. So back out to the home screen. And now we go back into matrix, select matrix A. We press our X to the -1 button, that's our inverse button. And then back into matrix, and we select matrix B. And we get the numbers 3, -5, and 8. Okay, so those are the values of A, B, and C. So remember, our goal was to write the equation in standard form. So we have y equals 3x squared minus 5x plus 8. Okay, and I have one for you to try. So you might just want to pause and give this one a try and then see how it goes. Okay, so I've taken each point and substituted it in for x and y and made 3 equations. And then I converted that system of equations into matrix form. You could use Cramer's rule, you could use elimination, but I personally think this is the fastest for me. And then I used my calculator and I typed in matrix A and matrix B. So what I have is the values 0.8, -1.4, and -10. And I would prefer to have those as fractions. So just a reminder, what we can do from here is press Math, and then number 1 is change to fraction, and then press Enter, and we get 4/5, -7/5, and -10. So we'll write that down. And then we can fill those in, and we have y equals 4/5 x squared minus 7/5 x minus 10. Okay, so wrapping it up with one more thing. This one is going to be an example of quadratic regression. So we have data, and we want to fit the data to a quadratic curve, not to a line. The Drama Club sells t-shirts as a fundraiser. The table shows data from the last 4 years for the price charged for the t-shirt, P. So P is price. And the total revenue earned from selling them, R. Revenue is the amount of money that they take in. So you can see when they sold the t-shirt for $8, they made $8, they made $1,180. When they sold the t-shirts for $10 a piece, they made $1,450, etc. Okay, so use a graphing calculator to find the quadratic regression model. Okay, so let me remind you what we do. We go into Stat, we go into Edit. If you have numbers in your list, you can go up to the list name, press Clear, and press Enter, or you can clear your memory. Let's type the prices into list 1, 8, 10, 12, and 14, and then let's type the revenues into list 2, 1180, 1450, 1675, and 1550. Notice how it went up and it went back down. So maybe what happened was people were willing to pay a greater price and they made more money, but then there came a point where it was just too expensive and sales went down, and so the revenue went down. Okay, so once we have the data in here, we go back to Stat, over to Calculate, and previously we did linear regression, but notice that right below that it says quadratic regression. So I'm going to select that and press Enter until I get to where it says Store Regression Equation. I'm going to go into Variables, over to Y Variables, choose Function, and choose Y1. That's where I want to store it. Press Enter. And there we have our quadratic equation with all of its constants. Okay, so that takes us through part A, or actually the part that was before part A. And now for part A, use the model to predict the revenue for a shirt price of $20. So if I go into Y equals, you notice that the equation is there. I pasted it in already, and I can go into my table set, change my independent to ask, go into my table, and type in 20 for the price of the shirt. They're only making $188.25 if they charge $20 for the shirt. Not very many people are going to buy it. And then the next question is, what shirt price would maximize the revenue? So we're seeing this as a quadratic, so it's a parabola, and it opens down. In fact, let's take a look at the graph. So what I'm going to do is go into my stat plot window, turn on my scatter plot, then go to Zoom 9, Zoom Stat, and that will set a good window for me. And there you see the parabola as well. So we're looking for the maximum of that parabola. So we can go into the Calculate menu, second trace. We can choose number 4, maximum. And now it says, give me a left bound, so it looks like it's to the left of the maximum, so I press Enter. Now it says, give me a right bound, so I move my cursor over to the right of the maximum and press Enter. And then go in between for your guess and press Enter. So the maximum is at approximately $12.35, $12.35 for the price of the shirt to give us a maximum revenue of $1,632.31. Now, I think that this chapter has been pretty intense and this lesson pretty long, and there's other things to do, so I'm actually not going to assign you any problems like this one, and I'm not going to test you on it. But I thought it would be valuable for you to see it because you need to understand that regression is not just for lines. It's for all different kinds of curves, and fitting data to a curve so that you can analyze it mathematically is probably one of the most important applications that we would get out of high school math. So I didn't want to skip over that completely, but I'm not giving you any of those to practice. I hope that doesn't hurt your feelings too much. Okay, so here's today's assignment. We did a little bit from 4.9, a little bit from 4.10, and I'm giving you a problem from the mixed problem solving set. Thanks, everybody.